Okay, I'd like to welcome you all to today's webinar on mission planning for aerial mapping. What we have definitely found here doing the webinars that we've been doing is there's a lot of people interested in mapping. So we're trying to create more and more content around mapping. That would be the best way of putting it. And with me is Aaron Woods. Aaron is new to us, used to be over at Pix4D. So as one of their trainers, so there is no better source of information, as I understand it, than Aaron, right?
Thanks so much, Kerry, for the introduction. I am very happy to be here and talking about one of my favorite, or two of my favorite subjects, actually, both GIS, or Geographic Information Systems, and drone mapping. Drones are really, I think, the ideal source to collect geospatial data, and it's certainly a growing field as more and more people are understanding or grasping the capabilities of drones for mapping.
Well, we're seeing in our webinars, we're getting almost 4 times the number of registrations for anything having to do with mapping than pretty much any other topic. So it's definitely a hot thing out there. A lot of people are interested. Well, what are some of the main purposes? What are some of the things people are doing with mapping that so many people out there do you think are interested?
Well, anytime you have a changing location or scene, like a construction site where you want to do monitoring of the progress of that construction over time, or if you have any kind of large facilities like a school campus or a university or even a large industrial corporate type of facility where you want to know where your facilities are and how things are laid out and be able to give people a nice 3D visualization or a digital copy of that is areas very popular. Also with real estate, folks like to have not just sort of the glamour shots of the real estate property, but something they can actually get in and do some measurements and actually sort of see a digital copy of what they're looking to buy.
I think a lot of people think when they think mapping, they think of it as one of two things, either construction and maybe agriculture. And agriculture is a very distant second. But what you just talked about is neither one of those things.
Well, and really the applications for mapping are vast, but you're right, I completely overlooked or didn't mention agriculture. And anytime you want to have up-to-date information with the conditions on the ground, Google Maps has been very popular and really introduced a lot of folks to the power of visual imaging and mapping, sort of like back not too long ago, we just had the fold-out maps you get at the gas station. And then Google came around and we were able to get visual data for updated areas for pretty much all over the earth, but really at a low resolution, only about 6 inches per pixel.
And the time frame.
And yes, you're kind of stuck with whenever that Google imagery was previously captured. So having access to drones to capture and document your own progress on your scene is a super powerful tool that is just ready for more implementation and activation by more people.
I mean, I go and look at Google Maps of my old house, which I moved out 2 years ago, and it's still showing my car in the driveway. So obviously not current information by any stretch of the imagination.
Yes, certainly so. And one of the great things about the mapping with drones is you as the pilot or as the consumer have the ability to dictate or order when that imagery is going to be collected on your schedule and on your timeline.
So we're ready to get into this now?
Sure. So whenever you're thinking about mapping, there's a few things you want to kind of get settled or set up ahead of time before you dive into a project very far. The first item being you want to determine what your project resolution, or ultimately what's called your ground sampling distance, or GSD, for that project will be. As I mentioned, if you look at a Google image, when you zoom in, a Google ground sampling distance, or the ground sampling distance for Google is about 6 inches per pixel, whereas if you're flying a Phantom 4 Pro, you can get less, like 1 centimeter roughly, or about 1/3 of an inch from about 100 feet high. So much higher resolution is possible, but you want to know ahead of time what your ground sampling distance expectations from either your boss or your client are. And then also you want to make sure you're really properly defining the project extent. My preferred way of doing that is to have the customer or the person requesting the map to provide me with a KML file that can be generated off of like Google Earth. That way we know ahead of time clearly what the delineation of the project boundaries are. There's nothing worse than going out and doing a project and trying to give it to the client when he says, oh, well, I also needed this area just over here. And if that's outside of the area that was scoped out ahead of time, then you can justify doing another project to capture that area. And then also you want to make sure you have determined ahead of time what your desired outputs for deliverables will be, whether those be a 2D or a 3D type of output, and we'll talk about those options here. And then lastly, you want to know about your project requirements for accuracy, or how close is close enough. Without any kind of geo-reference information, you can get fairly accurate data out of most UAVs, but it depends on really how you're measuring that accuracy, whether it be relative or global.
Okay. Why would you not always want the best accuracy or the smallest GSD?
That's a good question. And most of the times when you speak with a customer or a client, they'll say, oh, well, you can get 1 centimeter. That's what I want, the highest resolution possible. But to get that higher resolution data will require you to fly your UAV at a lower altitude, which could potentially put the UAV in, I don't want to say danger of horizontal or vertical obstacles that you might run into, but more specifically, it'll require you to capture more images to get the footprint of your project area, and ultimately require both more time in the field collecting the data and also more time processing the data, ending up with larger deliverables that maybe the customer doesn't really need. And ultimately, if you're hoping to print out maps on like an 8.5 by 11 type document piece of paper, you don't need to have things at a 1:100 or 1:1 kind of scale usually for that small of a printout.
Yeah, it makes a lot of sense. Chris is asking, do you think Pix4D will expand beyond DJI? Well, that's kind of a two-part question. On one hand, they already do. I mean, I've used my iPhone to do maps. I've used the Autel Evo 2 and the Autel Evo 2 8K to do maps. I've used all kinds of things to create the maps. Pix4D as a service doesn't really care about the image itself. They just need to have enough overlap for it to calculate the mapping data. Now, in terms of the automated flight, like Pix4D capture, well, that's not on Pix4D, that's on the UAV manufacturer to have an SDK, which is called a software development kit, so that they can create an app for it. Now, if I remember right, it already works with Parrot, doesn't it?
Yes, and in full disclosure, the Pix4D company is owned by Parrot, and Pix4D software is hardware agnostic, and it's a photogrammetry software that will work with images from really any kind of digital camera, or even like videos and things like that. And it doesn't have to be DJI, just DJI has the largest foothold in the market, if you will, and they do produce a lot of very amazing products that are very popular with most of the consumers. But certainly there are much, I don't want to say higher end drones, but or Pix4D can process images from really any digital camera, as you mentioned.
Right, but in terms of like Pix4D capture, that's limited to the aircraft that have a software development kit.
Yes, exactly. And they've certainly looked to and work with other manufacturers like Autel. Autel folks have their own inclusive sort of flight app built onto their controller, and Pix4D will process images from that. The SenseFly product brand of drones, the fixed wing, process those Wingtra drones. Really, it doesn't matter. It's just a matter of those developers have kind of exposed their inner workings for Pix4D to be able to hook into that SDK.
Right. So, Chris, you're saying you couldn't get it on your Evo. Now, I'm not really familiar with the Evo. I am familiar with the Evo 2. We sell those here. We just got a big stock of them, of all the different models. And on the Evo 2, you're not going to install the Pix4D capture app. The Evo 2's software, the Autel Explorer, has the mission planning software built into it. So you use their Autel's mission planning to set up the boundaries and the lines and all the details. You capture all the images, and then you take those individual photos and you either run them through the Pix4D desktop app or through the Pix4D cloud. So it doesn't matter what you're using to capture with the processing side is agnostic to the drone. I'm new to drones and have a DJI Mavic Air 2 with 4K resolution and 48 megapixel camera. Could this be used for mapping? Well, that's a trick question, Don, because on one hand, the answer is yes, as long as you are taking pictures with enough overlap for Pix4D to be able to process them. The other side of that is no, because there's no software development kit for the Mavic Air 2, so there's no way to automate the photo taking to make sure that you're getting proper overlap from image to image. Now, I don't know if DJI is going to come out with that at some point, but they have not announced it. So today, as it sits, the Mavic Air 2 is not a good mapping drone because it can't be automated to make sure you're getting enough images.
Having said that, there is a way to, we'll say, manually capture images to get a successful flight. I've even used like a DJI Spark before, if you will. And what you can do is, with the DJI line of drones, is they have the ability to turn on a rule of thirds grid, we'll call it, on your display or on your controller that'll give you essentially that tic-tac-toe sort of crossed line algorithm or pattern on your screen. And that effectively divides your screen into what we'll call 0, 33, 66, and then 100, or roughly 99% of the image. So as you're flying your drone forward, as you see an element come into the top of your screen as it progresses down over the screen, if you snap a photo as it first comes into the view, then as it comes down to that first third line and that second third line, and then again before it falls off, you will be able to achieve roughly 70% overlap and be able to get a successful reconstruction. However, the quality of the camera is, it's not a bad camera, but really the camera on the Phantom 4 Pro with that 1-inch CMOS global sensor is really more ideal for photogrammetry than what you'll get from a 4K video camera. That 4K video camera is ultimately going to produce roughly an 8.2 megapixel image, and that's not quite as good as a...
Right. The Mavic Air 2 has that 48 megapixel sensor, but it's 48 megapixels on a half-inch sensor.
Mm-hmm.
So it's you can't just look at megapixels. You have to look at sensor size as well.
The sensor size is certainly a big part of it. We have that here in the presentation we're going to talk about in a bit.
Is Pix4D capture available on Evo? Well, I already went through that, I believe. I don't know anything about the original Evo products, but on the Evo 2, you can do the mapping through the Autel Explorer app. What is the best free app used to plan the assignment? Pix4D capture.
Pix4D capture is certainly, I think, a very powerful and handy one, but really the other competing apps are, some have different capabilities. I believe there's a UGCS. I'm not sure, that's not quite free, but that allows to do terrain following. The folks from MapPilot.
He said free app.
Oh, free. Okay, yeah.
So Pix4D capture, that really is the only one I know of that's free. Lychee is good, but it's not free either. Pix4D capture is free. So if you can use it, it's the best free software that I know of. Richard, does the Autel software now allow cross-grid mapping? On the Evo 2, the latest firmware update and Autel Explorer app update now allows for cross-grid mapping. With Inspire 1, can you get accurate GCPs?
Well, usually the GCP, that term is a ground control point, so that would be like you'd want to, that's a point you would actually have on the ground. It's not something you really collect from the Inspire 1 itself.
Okay. Oh, MapPilot is free? I thought MapPilot used to be $9.
There's two versions of MapPilot. There's a MapPilot introductory version, we'll call it, and then there's the business edition version. And the business edition version does have a small fee to it. I forget what that is, but I've used it before.
I think I paid $9 because it had the terrain following.
Okay, possible, yeah.
Can Pix4D work without internet connection like an offline option? Yeah, on the processing side, absolutely.
Yes, sir. Well, the Pix4D capture application can work offline, but the one caveat is that you wouldn't get the background maps or the background data to kind of help you lay out where your project's going to be. But if you plan your project back in the office, you can essentially cache that information or download it, so you can then go out and use the Pix4D capture, have your background imagery, and be disconnected.
Okay. Boy, we haven't even got off the first slide here. What, in your opinion, is the best paid mission planning app then?
Oh, gee, that's a tough one. The UGCS is a very popular one.
UGCS has the advantage of being able to do linear, so like pipeline type inspection work, where Pix4D capture doesn't have that at this point. You'd have to do like a really narrow, it doesn't work well for that type of thing. I'll just leave it at that.
And the Lychee app is also a very popular one from folks I've spoken to over time.
Yeah, absolutely. Okay, well, we're getting way too deep into specifics of Pix4D capture and everything. We're going to save the rest of them for later on. Let's kind of get through the rest of the presentation here.
Okay, yeah. Our next topic is like going back and talking more about how you determine that ground sampling distance, because ultimately your GSD is going to be dictated by the altitude at which you're flying. And so fortunately, this algorithm that we see on the screen here, where the altitude equals your ground sampling distance times your focal length in millimeters divided by your pixel size in micrometer times 10, will roughly tell you essentially what your GSD is. And fortunately, the Pix4D capture application takes care of all of that for you. But it is important to know that you as the pilot, the one element you likely have the most control over is the altitude with which you fly, because you really don't have the ability to adjust or change your focal distance on the camera or the pixel size, or essentially the sensor size, if you will, of the camera itself. So that you as the pilot can really only alter or change that altitude to get what you were looking for. And so this QR code on this next screen we see here will take you out to a Pix4D support website where you can download what we'll call a GSD calculator, or a ground sampling distance calculator, that will help you determine what your ultimate ground sampling distance would be if you're using any kind of camera, really. And so we have a few examples here on the screen that using a Phantom 4 Pro 20 megapixel 1-inch sensor, if you're flying at 400 feet, that would be the same as 122 meters. You'll end up with a footprint of your image that's 121 meters by 182, and a ground sampling distance of about 1.3 or 1 1/3 inches. And so if you're flying then at 100 feet, or an altitude of roughly 30 meters or 30.5 meters, you get an image footprint of 30 by 45 meters, or a ground sampling distance of 1/3 of an inch, or right about 1 centimeter. And so this just kind of gives you an idea of what different altitudes will produce the sort of corresponding ground sampling distance you might be looking for. And so once you determine what your ground sampling distance is going to be for your project, that will then ultimately dictate what your overlap, or how to go about getting the overlap you're looking for, because you can determine the footprint of your image. And when you're looking at the Pix4D support documentation, it says that the minimum recommended amount of front overlap, or distance between each image, is such that you get 70% overlap in the front area and 65% in the side, and that's really the minimum. I found that I get pretty consistent good results if I'll fly, say, with 80% front and 80% side. That really gives me a little bit of cushion and wiggle room if I'm flying at a low altitude and I'm still trying to get the tops of my tree canopies to reconstruct well. A lot of times people don't take into account that if they're flying over a tall vertical object that's protruding out of the plane of the Earth, the top of that vertical object may not be replicated in as many pictures as an element on the ground. So by having additional front and side overlap, you have a better chance of getting those tall vertical objects to reconstruct well in your model. And then the last thing you really want to make sure you have well laid out and determined between you and your client is what is the area of interest, or the area to be expected to be mapped on the ground. And a key thing for that is whenever you're mapping a project with Pix4D, is we always encourage that you map slightly in excess by at least one flight line the area that you're trying to map. And if you look at the quality reports that's generated by Pix4D, one of the graphics called an overlap graphic gives you this nice red-green, or a green towards red coloration, kind of showing the amount of overlap in your project. And consistently, the edges of the projects will have this sort of striation of orange and red where there's lower overlap. So you want to make sure that you're not just mapping up to the edge of the area that you're interested in, but you're going slightly in excess of it to get good quality results all over the area you're looking for. And as mentioned earlier, it's always good to be able to get a KML file from your customer or the client. That way you can clearly say, this is the area on the ground you were looking for me to map, and this is the area that I'm ultimately delivering. And one thing just for safety I want to point out is it's always good to try to plan your flights not to exceed what I'll call 80% of your battery capacity. I've found that if you push your LiPo batteries beyond the 20% threshold or landing once your battery is at or below 20%, that will have an impact on the longevity or the length of the number of charges you'll get on that battery. So try to always plan your missions to maybe throw a battery warning at about the 30% and try to be landed by the time you get to 20.
Right. That's not to say that a mission should be less than one battery worth of flight. It's make sure you're on the ground at 20%, swap the battery out, and then you can hit resume and go back to the mission, and it will continue flying automatically. So that's what we're saying is don't push the batteries just because you're doing a mapping mission. It's it's not good for them.
Yeah, the Pix4D capture application does fully support swapping batteries mid-mission, but you just want to make sure that you have your fail-safe set properly within the DJI Go or Go 4 application, because Pix4D capture will respect those, and whatever battery fail-safes you've set in those will be reflected on the messages you get from the capture app as well.
Great.
And so once we've decided what our ground sampling distance is going to be and also the area that's trying to be mapped, make sure you know what your customer or client's expecting as the final deliverable. If your end goal is to have a nice two-dimensional orthomosaic image that can be used as a map for horizontal measuring purposes, then just a straight two-dimensional or a 2D map is really all you need. If you're looking for more robust 3D data, or maybe a 3D classified point cloud and a 3D mesh, etc., then you want to take into consideration maybe changing your flight pattern or plan up a little bit so you get more oblique imagery, so you have more data to reflect what we'll call the facades or the sides of those vertical obstacles, and they recreate or reconstruct in a more visually appealing, constructive way. And then also determine how frequently or how often a project might need to be repeated. If you're working for a construction site, they might want you to have you out on site once a week to map the progress, or maybe even if you're working on the construction site, they might want to have daily information for the project stakeholders. So know ahead of time how frequently you're going to be out mapping that project, and that can really help you determine what the scope is for the whole project going forward.
Right, and one that kind of plays into this is like doing stockpiles. That you got to have, the 3D data for that, and that's one of those where some of them want them daily, some of them want them weekly, some want bi-weekly. So it just depends on who you're working with to determine how often they're going to need those stockpile measurements.
Exactly. And then so once you've determined if you're looking for more of a 2D or a 3D output, then you can start getting into the Pix4D capture application itself and investigating different flight modes that will produce the different kinds of outputs. The first two on the left that you see here, called polygon and grid, those are really set up more to be ideally done for a 2D output. The camera angle or orientation on those flight modes can be set anywhere from 0 to 90, whereas the third option, double grid, it says for 3D models, with that flight mode you are unable to set the camera at a nadir or straight down orientation. So with the double grid option, you're forced to have at least about a 5-degree or 10-degree camera angle. I usually go with about a 15 or 20-degree camera angle, if you will, for good 3D reconstruction. But if ultimately you're not needing a super high resolution 3D model showing the undersides of trees and things like that, the option to fly a polygon or grid mission will reduce the amount of images you're capturing because you're not doing that double kind of approach. And just straight nadir photos will produce a very crisp, nice looking orthomosaic for the typical mapping purposes. But then if you want to have more of a 3D reconstruction, maybe for like an accident or a collision, a vehicular collision reconstruction, then using that double grid or the circular approach are really more ideal because the camera's at that oblique angle and you can see the sides of things that you wouldn't really see represented in that top-down orthomosaic view. And then my most favorite flight mode is actually the free flight mode. That provides you a lot of flexibility because you as the user can dictate how much spacing between front and side movements or horizontal and lateral movements that the drone will capture an image at every X units of measure, if you will. And so that really allows you to sort of do what we'll call a vertical grid if you're trying to inspect the face of a dam, or maybe if you're trying to get a good ortho plane, ortho facade, if you will, of the front of a building for architectural purposes. And so try not to over capture data, if you will, as far as if all you need is an orthomosaic image, the first two options, polygon or grid, are really the ideal choice. If you're trying to make a more robust 3D model for visualization of the sides and things, etc., that double grid or circular approach are really ideal, and free flight just provides a lot of flexibility.
So between double grid and circular, when would I use one versus the other?
The double grid works really well for what I'll call like an urban kind of environment where you have a lot of complex structures, whether it be buildings and houses and things like that, whereas the circular pattern is really geared more towards a specific, discrete thing you're trying to model, whether it be like a water tower, maybe a cellular communications tower, or even just two vehicles that have impacted and are at the same spot in an intersection. If you're not trying to map out a larger area, but you're really trying to create a 3D model of a feature, the circular would be the ideal approach, and the double grid more for urban environments. Or when I say urban,
Yeah, got it.
And then we also want to keep in mind what your project accuracy is. The amount of the accuracy of your project is critical, and there's two types of accuracy we want to talk about: absolute versus relative accuracy. And so if you take your GP or your drone out and you fly your drone, that drone has a GPS built into it. So the drone's going to capture geotag data more than likely, or should, for each image. Whereas maybe if you take your cell phone out and you're capturing images with a video file, you're just running video, when you go through and you break your video file down to individual images, you no longer have that metadata associated with it, or geotag data. So in the absence of having no geotags or having any kind of ground control point data on the ground, really there's nothing for the software to work with as far as scale and orientation. So a friend of mine did a short video of his newborn baby not too long ago, and after he did the video, he processed it up. But the little baby came out to be about 30 feet in height, and it wasn't really that difficult of a childbirth. And so not having a scale constraint limited the quality of that output. It was still a nice model of the young baby, but at the same point in time, the size reference was off. If you do have geotags alone, just from like the GPS on your drone, etc., you'll still get good relative accuracy. In my experience, having a known feature on the ground of a known length, I use something called the sky ruler. I find that element in length is 5 feet long, and typically I'll end up with a measurement of about 5.01 or 5.02, so just a couple hundredths of an inch off using just the geotags from the drone. And ultimately, a way that you can, if you're looking to get your data correlated very closely with data from, say, Google, you can actually go into Google and create some waypoints, if you will. They're not really waypoints; they're just points, if you will, on the map, and you can extract coordinates from that and use that to geo-reference your image to make it more closely match up with Google imagery. But really, you'll get your highest accuracy by establishing ground control points within your project that are being collected with a GNSS, or a Global Navigation Satellite System, essentially just a high-resolution GPS, like a survey-grade type equipment. That's really the best option. And then a thing you'll hear a lot with Pix4D, or maybe if you're also using RTK, or real-time kinematic drones, is the term for checkpoints. And a checkpoint is essentially really exactly like a ground control point, except it's the value or the location of that isn't fully exposed to the software until after the processing is complete. And then the software looks to see how accurate the checkpoint value is to the calculated value at that location, and that'll give you then ultimately the accuracy of your project.
Now, another time you'll see this phrase, absolute versus relative accuracy, is when it comes to positioning your map on the planet.
Mm-hmm.
So the relative accuracy, you'll get your map, and it will probably match up pretty good with what you'd see on Google Maps. You know, usually I can't even tell the difference, but if you need to have a higher level of accuracy because you're marking property boundaries, for example, then you need absolute accuracy to know exactly where your map is on the planet's surface. And that's also where the GCPs using a GNSS receiver are going to come into play.
Mm-hmm. Exactly, yes. And so what we see here on the screen now is an example of one of those scale constraints, or what's called a sky ruler, made by the Hoodman Corporation that we carry here at Multicopter Warehouse. And so this is a sequence of black and orange tiles that snap together and is exactly 5 foot in length. And this is a great thing that I encourage a lot of law enforcement folks to use, that if you set a couple of these down within your project, ultimately you can use them then to validate or to guarantee that the project is scaled appropriately, because you know each section is 1 foot in length or 5 feet for the whole thing. You can set what we'll call a scale constraint on one of these, making that 5 feet, and then that scale constraint will apply to all the elements within the project, and you can then test or measure the second one of these that you have down in your scene at a slightly different location and validate that you're still getting that 5 foot measurement, and that way you can prove that your project or your model is coming in with good relative accuracy, even though you may not have super high precision global accuracy. And then if you want a super high precision global accuracy, you really need to leverage an item like what we're seeing here. And these are ground control points made by the Hoodman Corporation. And these are great because they provide a really good high visibility target that you can find within your model or within your scene. And you set up your GPS, your high accuracy GPS equipment, essentially right on the center point of that target, collecting those values. And then you can enter that data within Pix4D, marking those points that are very easily identified by having the numbered ground control point there. And that'll allow you to get your data geo-referenced to what we'll call global accuracy. And that's really how you get the best quality results if you're trying to use this data for additional mapping or adding in with other GIS data. And then so once you've determined what the accuracy you need for your project and you've established ground control points, it's always important before you go out into the field to do a solid pre-mission check. And this is the area where you can catch things before you've gone out into the field and you may not be able to recover from it, such as firmware updates. I've been caught a few times where I go out to do a mission. As I fire things up, all of a sudden I find that my geofencing information needs updated or my firmware on one of my components is out of sync. So I always try to do a quick check of everything the night before to make sure that my drone, controller, all my batteries, and any mobile devices I might be using are all up to date with the most current firmware versions. And also, you want to make sure your batteries are charged, both on the drone battery, batteries on your controller, and of course your mobile devices. And what I've found to be one of my biggest limiting factors while doing mapping projects is access to power. If I don't have at least 6 batteries and access to a generator, I can't operate what I'll call continuously. If I have at least 6 batteries, by the time the first one's been drained and cooled a little bit, I can hook it up to a generator, get it recharged, and kind of keep working continuously. But you will be limited ultimately by how much access to power you have to how much area you'll be able to map. And then also go through and check all your gear, such as your SD cards. I'll make sure you have all your cables. I've been caught a few times without an SD card, or yes, not having an SD card or the appropriate lightning cable or whatever has cost me a trip to Best Buy on more than one occasion. So definitely do go through and check all your equipment the night before, make sure you have it all ready to go, and that'll really help your mapping mission go much more smoothly the next day. And then when you get out in the field, you want to do additional checks, if you will. Always conduct a pre-flight check. Both before I go out in the field, I like to look at everything on Google to kind of see what it is I'm expecting to encounter there. I do that back at home. And then when I get out to the site, I always like to do a quick walk around to the site just to make sure there's no kind of vertical hazards I'm not aware of. Also gives me a chance to check weather in the area and make sure I've applied for or have my LANC authorization or airspace clearance. And then also do some lighting check to make sure there's not areas of your project that may be encountering what I'll call heavy or dark shadowing. If the area is not well illuminated, it's hard to get good quality images for it and it'll not map well. And then lastly, consider what it is you're trying to map and model. You may find that if you're trying to make a 3D model of something, that the complex structure of it might require some capturing of manual or terrestrial data ahead of time. And so kind of think of the areas that you're trying to have represented in your final output and make sure you're capturing good quality images from the perspectives that you ultimately want to view or inspect your model or map from. And really, if you take all those things into account, you should have a very successful and productive mapping mission.
Yeah. Oh, okay. So hopefully that gave you some good things to think about, the introduction to the GSDs, the ground sample distance, measuring your accuracy, figuring out how to plan the mission, which type of missions you need to look at, all the things to kind of get started there. And we do have some more questions here. Most of these are going to be pretty easy. Does Pix4D capture allow for hover and shoot for sensors with rolling shutter? Yes, it does.
Yes, to a degree. We should clarify there's 2 versions of Pix4D capture. There's an iOS version and an Android version. And on the iOS version, there is an image capture mode. You have the option between safe and fast. And those 2 names don't really sort of spell out what's happening. In the safe mode, the software actually uploads each individual waypoint where each photo will be captured at, and the drone will fly to that waypoint, stop, hover, photo, then fly to the next waypoint, stop, hover, photo. And so that's the safe mode. In the fast mode, it simply uploads the waypoints for each end of the flight lines, and the drone will fly along that flight line and it will get a command from the controller at a set time, take a picture now, take a picture now. And so if you do have some kind of communication loss with your drone in the Android version of the app, you may have some dropped images. But the iOS version does allow for that safe capture mode and have the drone hover in place. Of course, that will slow down your data capture because it takes a little bit longer for the drone to start and stop each photo.
What's the best time of day you find to run mapping missions?
Another great question. So for those folks who are planning their own missions, usually that window between what I'll call 10 and 2, when the sun's at its highest altitude of the day, you'll have fewer or less shadows at that point in time. But depending on what you're mapping and modeling on, you may not have shadowing issues in all situations. And so whenever you can get good quality photos is really the best time. If you can get a good quality photo, you should be able to get a good quality end output from Pix4D.
Okay,
There's
a long question. Is there a way to take Pix4D capture projects on iOS and put them onto another iOS device? So I guess if you're creating them on your iPad, can you then move that project to your phone?
Not currently, no. That would be a great feature and something I encourage folks to keep requesting, because advanced mission planning like that I think is critical. And so using the Pix4D capture application at this point in time, there's not possible to save a mission on one device and access it via another, but that is something that has been a very popular request.
I don't know if you'll know the answer to this one. Any chance Capture will have an update soon to show what the camera sees with the Mavic 2? I know that's an issue. You see the camera view there, but it doesn't actually show anything.
Oh.
It's just black. Well, Aaron works for us, not Pix4D anymore, so I don't know if you have any insight into their software.
No, I don't have any insight into that, but I know it works with the Phantom 4 Pro.
But definitely complain to Pix4D about that, because I'm right there with you on that one. Does the capture software set the oblique camera angle for grid missions?
That's a great question, and for the double grid mission, you can set the camera angle to the angle of your choice. When you're doing the orbit or the point of interest mode, the circular flight pattern, the camera angle on that is, we'll say, fixed. You can use the gimbal controller, the gimbal knob on the controller to adjust the camera angle, but then the app will actually move it back down. So I think that using a point of interest flight mode within DJI Go or Go 4 and setting my drone to capture an image every 2 or 3 seconds as it's orbiting around is my preferred way to run an orbital mission using the Go app versus the Pix4D capture application.
Okay. He has a P4 RTK with the controller that has the ground station RTK. Is there any way to do a circular flight similar to what's available in Pix4D capture?
So you're using the Terra application, or essentially
it's the GS Pro that's built into the controller.
Okay.
And I thought it did. I actually thought it had a circular. I don't have one in front of me. Maybe that was only.
I thought it
did. So I'm not really sure.
Validate that.
Why can't you save a mission with a name?
That is a great question. That is a big shortcoming in the Pix4D flight app, and I guess ultimately you get what you pay for. And the Pix4D capture application is a free application that is at no cost. Some other applications like Drone Harmony does provide some of those kind of functionalities.
Yeah, I'm absolutely with you on this one, John. I've had to actually go in and look at missions to figure out which one it was that I wanted to fly, because I set up like 3 or 4 of them at home before I went out. I was like, yeah, which one is which? Absolutely with you on this one. Complain to Pix4D. That's what I'm going to tell you, because we have no control over that one. But yeah, I absolutely agree. And it was the same with DJI apps where you could save your waypoint missions and things, and they would just save by date. Okay, a couple of weeks later, you don't know which one is which. So yeah, that's a big one for us. Okay. Any other questions? Okay. Can you do renaming on the Android app? I don't think you can do it on the
No,
Android one.
within the Pix4D application environment itself, with the mission planning, unfortunately, yeah, the naming of missions is something that has kind of been bothersome to me as well. I can appreciate those questions and concerns.
But also look at Map Pilot, their free version. That's what I used to use all the time, because I'm so old that it was the only one that could actually come back when the battery got low and resume a mission. So that's, nowadays they all do it, but I've been using Map Pilot for a long time. What DJI airframe is considered to be the best, including recommended camera for all levels of imaging, including multispectral? Whoa, that's a kind of a trick question there. I would say today, probably it's an easy answer. the easy answer is it's the Phantom 4 airframe. But the Phantom 4 airframe makes up several different products. You have the Phantom 4 Pro, which is a decent machine for doing mapping.
RGB camera.
It's a good RGB camera. You'll get decent accuracy. It is definitely the go-to machine for many, many, many surveyors and architects and construction companies. Your next step up from there is the Phantom 4 RTK, which now you're going to go from $1,500 to starting at $6,000, if not $8,000 if you need a base station. Same camera as the Phantom 4 Pro, but you're picking up RTK precision. On the multispectral side, we do a lateral shift to the Phantom 4 Multispectral, which is the same airframe as the other two. Well, it's the same airframe as the P4 RTK because it has the RTK, but it has a multispectral camera instead of just a 20 megapixel, 1-inch sensor daylight camera. So on the Phantom side, you have really 3 different products in there that are good at doing different things. Your next step up from there would be going into either the Matrice 200 or Matrice 300 systems, in which case now your multispectral cameras are going to be Slant Range, Centera, Red Edge. There's a couple others. MicaSense, that was the other one I was trying to think of. And a good camera. And now you're doubling down on price again. So it just kind of depends on how you define best and how you kind of put those pieces together. But the Phantom 4 series is fantastic for what it is, and then you move into the much higher end.
And now, the batteries are compatible between all the Phantom 4s, so if you do have 3 Phantom 4s, the RTK, the standard, and the multi-spec, you don't necessarily have to have 3 fleets of batteries for each one.
Now, if you ask this question at the end of the year, or maybe hopefully not the first of the year, but somewhere around the end of the year, the answer may be different in that there is what's called an oblique camera coming for the Matrice 300 that will provide exceptional quality. I mean, it's 5 cameras in different angles. You kind of think of it as taking a 120 megapixel image every time. So the resolution is fantastic, but now you're, again, another exponential leap in cost on something like that. So how you look at what is best is kind of, what are some of the better paid mapping apps? Well, we've already talked about it. There's Map Pilot. Is it called Map Pilot? Map Pilot Business,
I think it's
right?
what it's called, yeah.
Because it has terrain following. Litchi's good. ArcGIS.
And then also 3D Robotics has a product called SiteScan.
Oh, SiteScan.
Which, if you're an Esri office, 3DR actually was purchased by Esri, I understand, and so that's actually a Esri suite of products now.
Can you process a 3D map with Maps Made Easy software? Absolutely. In fact, for a long time, well, even today, I often recommend Maps Made Easy for people who are getting started with mapping, because instead of a monthly or annual subscription cost like Pix4D or Drone Deploy, you're paying essentially by acre. You know, it's by blocks, but and a few years ago, I did a 42-acre crime scene for the sheriff's department, and it cost $16 to process. Now, for me, who does basically no paid mapping projects ever, you know, is it worth it for me to drop $4,000 a year on a software subscription? Well, absolutely not. So for me, Maps Made Easy is still a great solution. Wes is asking, what was that system again? I don't know what your system you're asking about.
Probably the camera, the oblique camera.
The oblique camera. It's called an oblique camera, and I'll have more information as I get more information. I don't have pricing. I just know it's supposed to be done sometime in Q4. So yes, Maps Made Easy, totally valid option. How does Pix4D work with thermal images? Can it handle radiometric images?
It needs to be a radiometric image, which is something that a lot of folks aren't really familiar with. They think all thermal images are the same, but some are non-radiometric. You get more of what we'll call a qualitative hot-cold information, but not an actual temperature. And so Pix4D can process thermal images that are radiometric. So essentially, we're talking the higher end of FLIR cameras. We're looking at the 540 by 6 or 640 by 520 kind of resolution. Typically, like the thermal camera that you'll find on the Mavic line of drones, the Mavic 2 Dual Enterprise, that camera is really not geared for mapping because of the low resolution. It's not really radiometric. But if you have a FLIR XT2 type camera or something like that, then certainly, yeah, you can use that. But you'll want to have a very high degree of overlap, roughly about 90 or maybe 95% overlap, because you're just dealing with so many fewer pixels that you need that higher redundancy to have the success.
Yeah. Oh, Johnny, I knew someone was going to ask this question. We've talked about the Phantoms, we've talked about the Matrice series, but I have not mentioned the Inspire series. And that's for good reason. The Inspire platforms were not considered industrial platforms. They were cinematography platforms or aerial videography platforms, and they excel at that. Does that mean you cannot do mapping with it? Absolutely not. That 42-acre crime scene I did with an Inspire 1 with an X5 camera on it. It just took me a lot of batteries because that thing was a freaking pig, you know, on batteries. So while everything we've talked about does apply to an Inspire 1 or an Inspire 2, especially if you're using like the X7 camera, that's a fantastic camera for doing mapping because it actually has, you can get the 24 millimeter lens with a mechanical shutter. It's fantastic. It just isn't, it's just not known as being that's a great mapping platform because it's such a good videography platform.
Yeah, and I really liked my Inspire 1. I used it religiously up until I got my Phantom 4 Pro, and then the Inspire 1 just sat on the wayside. And I looked hard at the Inspire 2 when it came out, but requiring 2 batteries to have the bird lift off, great redundancy for safety-wise, but a big cost investment that you have $300 in batteries going up in the air with every flight as opposed to just one. And so just return on investment that I wasn't doing cinematography kind of stuff, so I didn't really need the Inspire 2. But with the X4S camera, that's a solid aircraft and works well in heavy wind environments. It's just a higher price point for really the same quality you get for the Phantom 4.
Right, exactly. On the P4, you keep hearing about specifying the V2 over the V1. Is there any reason that you would need the Phantom 4 V2 over the V1? Absolutely not. The only difference is it went from Lightbridge to OcuSync, and the V2 came with the lower noise props. That's it. And in fact, in certain conditions, those lower noise props are worse for mapping. At altitude, they don't hold a position as well, and it just feels a little sloppy as you go up and higher up in altitude. If you're at sea level or whatever, they're awesome. They're great. But when you start getting into the 6,000, 7,000, 8,000 feet above sea level, those low noise props it doesn't feel the same. Let's see. How would you use a P4 Pro for agricultural mapping? Well, that actually goes a couple different directions. You can do it for mapping the field and getting altitudes and some crop heights and things like that, but you're not going to get NVDI data or multispectral data that will show you the health of the plant or the nitrogen level or things of that nature.
Yeah, for true agricultural type of work, you really need to have what we'll call narrowband multispectral camera. And when I say narrowband, like the DJI Phantom 4 multispec has 6 sensors on it that are detecting very narrow bandwidths of light energy. Whereas if you're using just a regular RGB camera that captures all the broadband kind of data, you can calculate a rough NDVI calculation if you also have some red edge information to add to it, but you don't get real true vegetation analysis out of that. You really need to be using a agricultural specific multispectral camera to really be able to tell true analysis of a field.
Using Pix4D with a Mavic 2, is it best to set the picture trigger mode to safe mode?
Well, being in safe mode, we'll have the drone stopping at each photo location. So for smaller project areas, yes, it would be better, but ultimately you'll run into issues where you're just not able to map as large of an area, and everything's a trade-off, if you will. If you have good quality light, then the linear rolling shutter distortion isn't severe on the Mavic line drones, but it's just not as good.
One of the suggestions I have when using a drone like that is to increase your ISO a little bit, like ISO 200, ISO 400 even. You're still not going to pick up a lot of grain at all at ISO 400 on a bright day, but what it allows you to do is set a much faster shutter speed, and that is what's going to help alleviate some of the shutter issues with it. If you're running ISO 100 and f/8, well, your shutter speed's not going to be that fast, and you may pick up motion blur and things like that. So upping the shutter speed, opening up the aperture if you have an adjustable aperture, and getting that shutter speed as fast as possible is going to make the big difference. Okay, Jeffrey here. How about Open Drone Map? I've tried to install it once, and granted, it was like a year and a half ago, and I couldn't even get it to work. I guess it's easier now. Have you any experience?
I haven't used it recently, and I tried a bunch of software before I invested in Pix4D a few years ago, and it did work, but it required a lot more of computer savvy user on the front end.
Okay. In a pinch, can a Mavic 2 Enterprise Dual work for vegetation? Well, if you're talking about thermal, it's going to provide a certain level of information, but it's not going to provide multispectral information. One thing that is very useful when you're using just a thermal camera in agriculture is water runoff. It's very valuable for that to see where are things dry versus where are they wet, because that's going to have a temperature variance. So my question back to you, you're asking if it can be used for vegetation. My question back to you is the data that you're working with reliant on a difference of temperature? If it is, the answer is yes. If it's not reliant on temperature differences, then the answer is no. It's kind of a simple question that way. So in some cases, thermal, it can be used for different types of agricultural work. There's no doubt. In others, it's just not going to provide the data that you need.
And yeah, the data from the Mavic 2 Dual Enterprise, you won't be able to get that processed through Pix4D for mapping purposes.
The resolution of the Mavic 2 Enterprise Dual camera is just really, really, really low. It's 160 by 120.
Yeah, it's more for qualitative assessment. Yeah, hot, cold, good, bad, but not really quantitative of different degrees.
Right. Now, a decent aircraft that we just got in is the Autel Evo 2 Dual, because the thermal on that is 640 by 512. That doesn't solve the complete agricultural vegetation analysis issue. It just gives you bigger images that can be processed through something like Pix4D.
And the sensor on that camera, the Busan sensor, is a radiometrically accurate sensor, so yeah, you can do mapping with it.
Okay, guys, thanks so much. Definitely appreciate you all attending and spending some time with us this afternoon. We're coming up on an hour, so we want to try and cut it off. Every single slide here has had our email address on it, enterprise@multicopterwarehouse.com. If you have any questions, or if you want a trial license for Pix4D, I can provide that to you as well. So hit us up at enterprise@multicopterwarehouse.com. Happy to help you out with anything. Watch for an email maybe later today. If the processing happens fast enough, I'll get out the recording of this so you can share it with whoever you want. And thanks for joining. Thanks, Aaron.
Thanks so much for having me.
All right, guys. We'll catch you all next time. Bye-bye.